Hello everyone, we're back to RC parallel circuits. So I have a resistor and a capacitor and they are in parallel with each other, and the power supply. An AC power supply that puts out 240 volts. I've given you the value of 30 ohms of resistance, and I've given you a capacitance of 132.63 microfarads. So the first thing I'd want to do is convert those microfarads so that I could figure out what the XC is. What is the the capacitive reactance of this circuit? What is the XC? I've got to make room here. Okay, thank you. How do I solve for XC? XC is equal to 1 divided by 2 pi, the frequency, and C. So in this case, we know, we've talked about it before, we know that pi times 2 times 60 hertz, and that's what we're going to assume every circuit is 60 hertz unless I tell you otherwise, that 2 times pi times 60 hertz is 377, or close enough, and then we're going to multiply it times the capacitance. Here's the thing, you got to remember that that is a 132 microfarad capacitor, so that means I need to move that decimal place 6 places. So I'm going to end up at 1, 2, 3, 3 more zeros in front of that. So let's put that in here on the formula. 0.000133263 as a value for a 132.63 microfarad capacitor. So if I do that, if I put that in the calculator, 377 times 0.123133263 equals, and then I have to do 1 over x because we're dividing it into 1, remember, so 1 over x comes out to 19.99. I'm going to call that XC is equal to 20 ohms. So let's write that in there. XC is equal to 20 ohms. So now what do we know about a parallel circuit? We know that voltage should be constant across each branch, so the voltage can be filled in quite easily here. 240 volts. 240 volts. We can also solve for Z now because I have a ohm value in the capacitor and an ohm value for the resistor. So let me solve for Z. This has got a different formula than series, so Z is equal to R times XC divided by the square root of R squared plus XC squared. So we know what XC is, but I want to go back and make sure we know that R is 30 ohms. That was a value that I gave you to start with. So that would be 30 times 20 divided by the square root of 30 squared plus 20 squared. So I know that 30 times 20 is 600. And let's figure out what the value is down below. So that would be 30 squared plus 20 squared, and I'd hit the equal sign, and then the square root of that is 36.055. 36.055. So in this case, if I solve that, I will know what Z is equal to. 600 divided by 36.055 equals 16.641 ohms. That's our ohm value. Our total impedance, Z, 16.641 ohms. So now we know the total impedance of the circuit. Let's go back to the resistors and let's start solving for I and for P. I know that I can solve for I if I have E and R, so it would be E divided by R, and that would give me the total current. So let's do IR is equal to ER, can't see that, can you? There you go. Is equal to ER divided by R, and in this case that's 240 volts divided by 30 ohms And my calculator tells me that IR is equal to 8 amps. That's 8 amps right there. Now, I can also solve for P while I'm here because I know the E and the I. We know that P is equal to I times E, or the amperage times the voltage. So let's solve for the true power. P is equal to IR times ER, and that is 8 amps that we just solved for times 240. So if I do that out, 8 times 240 on my calculator equals 1,000. P is equal to 1,920 watts. That's what we're solving for, the wattage or the true power. And I'll write that in here, 1,920 watts. Now back over to the capacitor. I can solve for the current flow through the capacitor because we know the voltage is the same in each. The current is going to be different. So if I'm solving for the I need to know the voltage and the resistance. That's one way. So if I know the voltage and the ohms, the EC and the XC, I can solve for IC. So let me write that down here. IC is equal to EC divided by XC. And in this case, we know the EC is 240 volts. And we also know the XC, the EC is 240 and the XC is 20. And my calculator in my head tells me that 240 divided by 20 is 12 amps. So I can fill that in right there, 12 amps. And if I'm solving for VARs C, or volts amps reactive of the capacitor, I can multiply the I and the E. So let me write that out. Maybe if I can squeeze it in here. VARs C is equal to IC times EC. And in this case, that is IC is 12 amps times 240 volts. Am I doing that right? Let me check. Yep, 12 amps times 240 volts. So 12 times 240 equals 2,880 VARs. VARs C, the volts amps reactive. And we'll write that in here, 2,880. That fits in there just fine. So now I could solve for IT by multiplying the by dividing ET by Z. That would be the voltage divided by the total impedance of the circuit. I could solve for that. But there is another way to do that, because this current in this resistor and the current in this capacitor are out of phase 90 degrees. So we can use a different formula. Let's take a look. I've got IT is equal to the square root of IR times IC. Excuse me, these got to be squared. Boy, I really messed that whole formula up. Let's straighten that out. I don't want to confuse you. IT is equal to the square root of IR plus IC. And these are both squared. All right, so let's plug in those numbers. IR is 8 amps, I believe. Yep. IR is 8 squared plus 12 squared. So let's punch that into the calculator. 8 squared plus 12 squared equals, and then the square root of that tells me IT is equal to 14.42 amps. So the current for the whole circuit is 14.42. With that information, I can solve for VA. I could use the VAR C and the and the true power to figure out the apparent power, or the VA. But if not, I can use the another formula, right, for VA is I times E. So IT times ET would also give me the VA. So let's see. VA is equal to IT times ET. And in this case, IT is 14.42 amps times 240 volts. See what that comes out to. 14.42 amps times 240 volts equals, the VA for this circuit is 3,460.8 volts amps, or apparent power. 3,460.8 VA. Great. Now we can figure out what the power factor is. And for power factor, we can use the true power, or P, the wattage, divided by the volts amps, or the VA, or the apparent power. Almost wrote that in there. VA. So in this case, it is 1,920 divided by 3,460.8. Let's do that on the calculator. 1,920 divided by 3,460.8, and that equals 0.5548 as our power factor. And we can write that in. And from there we can solve for angle theta is equal to cosine, right? So at that point I put in 0.5548 and it comes up 56.3 degrees. So the circuit is 56.3 degrees out of phase. And we've solved all the values we need to solve for a parallel circuit. Thank you.